We are really privileged to welcome each one of you on the first webinar of MRO Digest Forum. MRO Digest Forum is an informal think tank, basically a think tank which is into the domain of idea generation and in facilitation of anybody and everybody who is willing to be partner of the country's growth. It looks at all domains of maintenance, repair, overall or operations, the way you define MRO, whether it is the civic field or the defense forces or paramilitary field, anything where the equipment exists, MRO is related to that, and this think tank looks at the challenges and the solutions in that particular field. The subject of discussion today is 3D printer and its uses in the defense forces as well as in the industry. We have number of experts on the issue. You would have seen in the news today that a private company has created single engine for projection of satellites in the space through the rockets. The statics testing has been done today, and actual test run is scheduled sometime between 12th and 16th of November. This indicates the potential of 3D printing, the kind of accuracy it brings in, and number of other things which we will be exchanging in the today's conversation. We shall commence the proceedings with the keynote address of General N.B. Singh, our patron. General N.B. Singh, for your information, has served as DG EME, DG IS, besides being the founder member of Armed Forces Tribunal at Jabalpur. He specializes in armored fighting vehicles and has played a key role in the design and development of bulletproof vehicle Takshak, Arjun armored recovery vehicle, as well as Dhanush gun system. He has actually undergone specialized training in Germany on off-highway vehicles, besides having served in Moscow as military attaché technical. In fact, his credentials are a matter of envy for all of us, and we are all proud of him that he has consented to give the keynote address. So without taking any time further, I, Major General Dr. Ashok Kumar, your moderator for this event, now invite General N.B. Singh for the keynote address, please. General N.B. Singh.
Thanks, Ashok. Yes. Good evening to all of you. It's a great privilege for me to be here to commence the proceedings by delivering the initial address. Actually, in these kind of seminars or webinars, it is the main actor, the main speaker, who is, of course, the star of the occasion. All others are needed to hold the event, but people don't expect them to say much. So I will therefore keep my address very short and precise. And we'd like to just mention that additive machining or 3D printing was preceded initially by additive remachining, I'll say. It was extensively used by the overhaul industry abroad. And there was one technique called rototack, which was extensively used for reclamation of crankshafts, where metal was sprayed on the crank pins under an arc, and thereafter, when it solidified, it was taken back to the grinding machines and all that, and the required surfaces ground. And in this way, the crankshaft could be reused with just 10% of the cost of a new crankshaft. Subsequently, when the IT industry came up, then of course, this 3D printing started off initially with stereo lithography, thereafter with fuse deposition modeling, And somewhere around 2010, 2012, the selective laser sintering method came up. And now you have seen the last 1 decade, lot of progress has taken place. For me, I feel that the military till date, especially the army, has not used this technology very well. Whatever few numbers we see is basically for demonstration purposes. But I can just recount how the US Army was able to learn from the lessons of Desert Storm and Iraqi freedom, where they found that despite the ability to airlift a lot of logistics from the mainland, their average wait out of time for any urgently required spare part was about 14 days. As a consequence, in Afghanistan, they deployed 3D machining labs. They were very expensive, about 2.8 million, so somewhere upwards of 20 crores. But then the advantage was that they could bring whatever spare was needed, whatever item was critically required, they could do it in about 6 to 8 hours. I'll give you two examples. One was they introduced a new IED, and this IED had a lot of bulky batteries along with it. So one of the soldiers said that, why can't we get an adapter made which will allow us to use the standard military issue lithium batteries for this purpose? So the lab was given this job, and within 6 hours, they were able to make that adapter. As a result of which, in that company, every man was saved the task of carrying 2 kgs additional load. Similarly, the M1 Abrams tank, they found that the mounting of the thermal cameras used to break very often. This job was done in situ at a cost of $40,000, whereas the original one, because in these mounting brackets and all, to be able to make it, you need a large amount of parts. And then they are separately machined, joined together, welded and soldered and things like that. But here you could just make it ground up, the whole bracket, and it was used there. So what I'm trying to tell you is that normally it is said that logistics drive operations. And you have seen this example in Ukraine, where the initial advances were affected because the logistics couldn't catch up, whether it was ammunition, whether it was engineering support and whatnot. But I feel that 3D machining, if properly employed, can become a disruptive and a game-changing technology, because you will find that for the first time, operations. So I feel that this remarkable change will come in case the army and the military adopts this with open hands. Obviously, today the problems are the cost, but as it progresses, you'll find the costs will come down. But I feel that if you are able to make a critical part, a firing pin or something like that in the stride, there is nothing better than that, especially when the combat operations are on. So with that, I will now hand you over back to Ashok for proceeding with the rest of the seminar. Thank you.
Thank you very much, General NB sir, for setting the tone for this webinar of today. Now, gentlemen, I shall introduce you with the main speaker of the day, Group Captain Ashok Singh, who is a postgraduate mechanical engineer and who has served in Indian Air Force, defense, public sector undertakings, and multinationals in wide-ranging capacities over more than 2.5 decades. That is the kind of expertise which he carries with him. In addition, that he also holds an MBA in HR. He has served the manufacturing industry even when his career began. He was with MRO responsibility with Mi-17 fleet. He also has a detailed expertise of working on UAVs, both Searchers as well as Herons, and he is currently involved in 3D printing, and which needs attention of all of us to hone its multiple uses. So now I hand over each one of us to Group Captain Ashok Singh for his presentation. He will be covering the 3D printing in detail for next 30 minutes. Whatever queries you have got, please keep noting down. We will handle them at the end of the presentation, and you'll be given adequate time for that. Over to Group Captain Ashok Singh.
Thank you very much, sir. I'm Group Captain Ashok, a veteran. Thank you very much, General N.B. Singh and General Matharu, and thanks to the august participants, both from the services and from the civil. So I would like to start straight away. It's 3D printing, also known as additive manufacturing or rapid prototyping. Its application for industries in general and for military in particular. What I would envisage is that it would be making our forces more effective in its mission successes, be it in peace or at war. So what we see is, like, you have a BMW motorcycle, and BMW has used its mind very well. They have put a small 3D printer at its back, and this helps to support people who are using BMW in their maintenance, getting their spare parts on demand, on site. And I think that, like, it's something very apt for MRO industry moving ahead. So I had encountered personally a couple of times or many times where we are dealing with 3D printing technology, and we go to the end user whom we feel that he or she would be a good prospect. And when we say, like, hello, we would like to talk to you about 3D printing, and they say, look, kindly look at IT center or IT department. And then, like, it's sometimes it takes us a little while before we make the point home that what we are dealing is with machine. It's not something which like pure IT. So that's about little misnomer people have. And still a lot of gray is there between the black and white. Coming to somebody from Saint-Gobain, they said that we had 100% return on investment within 6 months of purchasing a printer. So still, like, you know, most of the time it is said that it's very expensive. So it depends, like, what is your need and what is the circumstances, and that would determine whether it is expensive or not. I would give you one example, which is from Vedanta. It's a well-known global company, and they have a mine that are operating in Jharsuguda. It's a hinterland. There's not much of connectivity. Now, of course, one airport has started, and they were finding it difficult to maintain their machines. Most of the critical parts were being imported, and therefore what you see is, like, the seal kits were getting ruptured, and if you really see, they were taking almost 45 to 90 days for getting the part. And it's a small part for which the entire, like, say, auto bath used to come to a grinding halt. With this 3D printed part, they could find that they can use it well, they can get it within 4 hours, and it has saved them, I think, a very substantial amount they have not shared. Similarly, there's one more part where it's in a forklift, and again you have a continuous carbon fiber reinforced seal, and this they could produce in 2 hours. The import time used to be 45 days. So if you see, for 45 days, if your machine is lying idle, in a commercial parlance, it's quite a huge amount of money. So before I start, like, I would say there are Newton's laws. There are 3 laws of human behavior. Law number 1 is akin to Newton's first law, where it says that, you know, you would follow the status quo unless it is acted upon by a decrease in friction or increase in fuel. So it is basically, if you are nudged, and then how you would behave would be an outcome of you and the environment. And lastly, your decision is law number 3, where you always evaluate as what are the consequences going to be, whether status quo is better than a devil in terms of consequence coming and hitting you. So my aim of presentation is not to delve for a deep dive into technology, but to enhance the level of awareness of all who happen to be here and harness the 3D printing technology and use it. It is for you, your organization, and our nation, and I'm quite sure about it. Looking at the Indian government, most of the time we are lamenting that the government isn't doing well, but to my mind, government is doing excellent. They are very aggressive, they are very encouraging and very supportive. Atal Innovation Mission, which founded that Atal Tinkering Lab, they have got more than 10,000 schools where you have these ATL tinkering labs, and each lab has got a 3D printing machine, and they have a module where they teach you 3D printing. So that's something excellent, and what you would get will be neoteric innovators. I'm sure in a couple of years' time, they would be romping the streets of the entire country and the world. What the central government says is that their aim is to have 5% share in global 3D printing market by 2025 or 26. And it translates to $1 billion of GDP. While in 2025-26, the world market would be about $5 to $6 billion. So how do we take the nation there? So I would say that let's put our heart and head together to do that. Now, Ministry of Electronics and Information Technology, they have come out with a beautiful publication which is called National Strategy for Additive Manufacturing. And it's a very well written, well structured publication. And I think it's something, if somebody goes through, it will spell out some kind of clarity what the government is looking at, and it will help him or her to have a clarity of his or her own. What the vision says is that it should be looking at Make in India, Atmanirbhar Bharat, and position India as a global hub for additive manufacturing, development and deployment, like we are globally well ensconced in terms of automotive industry, in terms of IT industry, and create and protect the integrity of India's additive manufacturing intellectual properties. Now, a little bit of history. General N.B. Singh just had spoken a little bit of it, so I will just rush through. The question is always that it's a disruptive new technology. To my mind, 41 years back, it was like it had its advent. So 40 years, whether it is young or old, it is for us to decide. I would leave it to each one of you. I would divide, or like it's normally said, that we have got first generation of 3D printing when it had its advent in 1980s. Then by 1988, you had SLA coming in. 1990, you had FDM and SLS coming in. And if I do fast forward, then we are in second gen. We have like functional parts being produced by 3D printing. You have biological parts. Living Heart Foundation, they have done a 3D printing of a heart, full heart, and it has been used in a surgery. And they have used a kidney which was 3D printed. Now they are developing tissues. So like whole lot of work is going, and it's quite. This is totally my way of looking at it. Cellular phone and 3D printing. Cellular phone technology, I'm sure all of you know, is a very, very high cutting edge RF technology. But the beauty of that technology is that we don't have to go into Laplace series or Fourier series or Laplace transform equations for telecommunication. But then we can use it, and a literate or an illiterate guy can use a cell phone with ease. Similarly, 3D printing is high-tech technology. At the same time, it doesn't require a degree in engineering or anything like that. It can be used by anyone and everyone. So that's how it's like something which is quite adaptable and user-friendly. Now, 3D printing, its applications, I'm sure most of you know about it. So it's like on-site, on-demand manufacturing. It is for prototyping, and it could be for design considerations. And it's like there's no industry today which is not using 3D printing. Now, there are two kinds of 3D printing. One is with energy directed additive manufacturing, and another is material deposition. And there are some of them which are using both of them, which find the intersection in terms of ledger metal deposition, inkjet binding, and laminated object manufacturing. I would leave it here. Now, like being people from the forces, I would look at the Ukraine-Russian war. Now, what it has done. So if you look at it has created something where we all need to learn, and I think everybody is learning a great deal on how the war is being fought and how it's supposedly going to be fought in future. And India being juxtaposed between two aliens, we think that we have to tighten our belts and be always ever ready and prepared, and as such we are. So the Polish entrepreneurs who are in 3D printing, they have come up in mass to help Ukrainian army to manufacture tourniquets, periscopes, drones, and they have also helped them with 3D printing machines so that they can do it themselves. There's a Project Diamond. This is based in the US, where it is called Distributed Independent Agile Manufacturing on Demand. Now, this is being used to help Ukraine get whatever they need, especially for medical and healthcare, because a lot of people are getting injured in the war, and both civilians as well as military. So you can use the 3D printers, which could be in any part of the geography, anywhere in the world, and you can pass a STL file over the cloud and you can get what you want. So that is something great. Looking at 3D printing. Now, I was quite amazed when you see Ukrainians and maybe Russians, I don't know, they are using 3D printing, 3D scanning to scan their, heritage sites. And something which is very, very ingenious and innovative and forward-looking, where like they will have a scanned CAD file, and then tomorrow, in case when they have to rebuild, they can rebuild the whole building the way it was once upon a time. The war is going to be for a long drawn process, and it's been already 7-8 months, and the boys and the girls have to go to school, and schools are demolished, destroyed, bombed, and so you have 3D printed school, which is already one up and running in Ukraine. Something to be noted for the military professionals is, like, Russia is facing a big challenge in terms of all the support which has been withdrawn from Russia by American and European companies in 3D printing. It's not only in 3D printing, but even companies like Coke and Pepsi have wound up and gone. So they are in like great grief, I would say, because I have had some personal interactions with them. Czech, they are also coming up with anti-bank barriers. It is in the civil construction domain. And then they have also helped them with the 3D printers, where like Ukrainian army can 3D print an anti-tank barrier wherever they need in the field itself. Germany, they have helped them with making a Russian radar jammer, so they can have that air defense edge. So something which has, every nation not at war with you can work against you, even nations like who are not. So this is something quite peculiar here. Russians are also using 3D printing. They're using it. One of the uses to maintain their MiG-31. It's a legacy platform, and there are many parts which are not there. But then with 3D printing, they have been making it up and running. Coming to why, like 3D printing, be it like most General N.B. Singh said that in the army they don't have 3D printing or 3D printers. The reason why somebody won't have bought is primarily money. Like whenever you go to somebody and say, look, I would like to talk to you, the question is how much it is. So if it is, say, XYZ dollars, they say it's too much. Anyway, so it doesn't make how does it make a business sense now? So if you see defense and aerospace, 3D printing market is expected to reach 5.58 billion by 2026. Quite a big chunk. The growth rate is 24.3%. It's something quite phenomenal if you see, compare it with any other industry. what the research says is that the Asia Pacific region is going to see the fastest CAGR growth, and that's encouraging for India. Indian 3D printing market as of today is $92.34 million. And the forecast is that the growth is going to be 20.33% CAGR by 2028. So it does make business sense, and that's how like a lot of people are entering into this arena. And I'm sure it would make business and operational sense for the forces. There are 33 types of listed 3D printing technologies. I won't speak about them, but this is for the academic interest that it's been put there. FDM, SLA, DLP, SLS, DMLS, SLM, these are some of the well-known ones. So there are multiple of them, because not one of the technologies may not be one-stop all solutions. So there are different solutions for different kind of 3D printing. Could be for medical world, automotive world, could be for space and things like that. Now, how does the globe doing about 3D printing? It's like most of you would know, and I just put some snippets from here and there just to make a collage out of it so that it works out to make some kind of a implication or analysis out of it. So Boeing and like the Joe Biden has come up with the additive manufacturing program. So that shows like how well the American government is looking at it. And Boeing and Northrop Grumman has joined him. Boeing has established a center of 3D printing long back with a company called Stratasys. And long back, they had printed a whole wing of a aircraft. A very, very surprising phenomenon. But their tests and trials are going on. Now, UK, they have 3D printed drone swarms. And today we know like how drone is working wonders in the war which is just happening. Now you have rocket engines which are 3D printed, and rocket engines are using 3D printed fuel. And that is already tested, and they have tested it successfully. Probably they would be making it operational in due course of time. French Navy, they have printed a ship propeller, and it's almost 1 meter in dia, and it's like quite a job. And then coming to medical field, one prosthetic eye has been put to Steve Burgey. That was in November 21. Of course, prosthetic limbs, etc., are already there for a long time. Looking at Indian scenario, Andhra Pradesh MedTech Zone, I would request that if anyone gets an opportunity, they must visit this place. This is a beautiful place which worked 24/7 during pandemic, because they were the ones who started with developing RT-PCR kits, and they were putting 3 lakh RT-PCR kits every day. And they were using 3D printing in a great manner. Today in India, if I know of, the biggest 3D printing setup where a versatile and variety of 3D printing technology is in one place is ANTZ. And they are actually working on artificial organs and for bioprinting the same. So it's a lovely place. One Dr. Sharma is leading this, and he is a fabulous man who worked with Johns Hopkins Hospital in the US. And Johns Hopkins is running a program called Living Art Program, where they are working on, producing a 3D printed helmet. Wonderful news is that Divide by Zero, a company based out of Pune, they are exported a 3D printer to the US. Fabulous. We have a 3D printed house last year, and Indian Air Force and the Indian Army has got 3D printed house, and that's a fabulous work done by MES. Shows that they are forward looking and they are coming abreast with the cutting edge technology. Objectify, it's a company which is in multiple locations in India. They are partnered with Airworks for the aviation MRO. Incredible AIM, which is in Pune, they have delivered 600 3D printed patents in implants. It's quite a phenomenon, I would say, if those who are aware. Otherwise, these were all being imported at exorbitant costs. MS Solutions, Bangalore, they have developed a metal 3D printer. And here I would say that armed forces should look at some of these companies which are developing indigenous 3D printers and those who are developing indigenous materials, where they join hands and support each other so that we are indigenous in due course of time. Atmanirbhar. You have a DRDO doing a aero engine repair and HL developing a aero engine part. So it's, and when Intech and aero engine, if you see, it also involves Semilac, and therefore Semilac is well embedded here, and they have done a very good job, and the Tango has gone very well. Looking at the armed forces in 220 MEs, they have done defense like Southwestern Command in the Air Force. They printed houses, and they have also printed sanitary blocks for standalone laboratories in field area near Jaisalmer. Then UAV, which is done by IdeaForge, it's all 3D printed. At DRDO in ARDE, I have personally seen this particular pistol is being developed. It's a combined work for the Army and the DRDO scientists. And it's like, it has used a tremendous amount of 3D printing. HL has signed with Wipro 3D, something where they would like to jointly develop and help each other. It makes business sense and it makes a progressive business practice, something with the forces also can look at adapting. IAF has definitely established a center for 3D printing in Nasik, and I'm very happy about that. And I'm not sure, but this is from all open source that more than 300 items have been already 3D printed and they are in operations, and it's a fabulous job. But it's just the way we have started is the tip of the iceberg. We have a long way to cover. Semilac has been very well involved. One of the gray areas is, material certifications, process certifications, machine certifications, and therefore I found that Semilac has done a great deal of job, and they have gone hand in hand with the end users, both 3D printing companies and the forces. And we have things which are there sitting in the aircraft, aerial platforms, and flying. Now coming to why 3D printing for Air Force or armed forces. So it's something which most of you know, like the small batches are there, means volume is low. You can have distributed manufacturing. Say, look at aircraft, say if we have Su-30 in 10 locations, then you can print something and make it available for that Su-30's MRO, which is close by. Then, of course, legacy and obsolescence management and reverse engineering. And then, of composite tooling is like, it takes time, it takes energy, it takes resources, and at the same time, it takes multiple iterations before you get the right tool. And here in 3D printing, you don't need that. You can directly print an end-use part, and therefore it's a suitable technology for especially aviation MRO. Wars have been won or lost primarily because of logistics. So here you have got logistics redefined through 3D printing, where you have got instantaneous MRO parts, you have got a digital inventory, and optimizing for performance. Unfortunately, despite that, I had talked with many people in the forces, in the services, where I say that you start with digital inventory, at least identify 100 items and make a digital inventory. But I don't know. I think the day is going to come soon where we will have a couple of digital inventory files, and instead of holding in your racks in the warehouses something, you would be holding something as a digital file. The US Army, they have got something like a portable 3D printing factory. General Endrising was mentioning about that. So they have something called rapid logistics or combat logistics, where you can produce what you need at the place where you need. And that's how you can make your operations most effective. Like Sir was telling that it takes 14 days for a critical spare from the US mainland to maybe a country like Afghanistan or Gulf war locations, and now like Ukraine, probably. So when you have a 3D printer in a part as a part of your rapid logistics, you can obviate all those delays. One such small 3D printer is like X7 from Markforged, and this is like helping somebody to put it in a case, and then you can carry it to the field and produce the parts what you desire or need. Now, most of the people have a little kind of suspicion or anxiety about, whether the parts will work or not. But today we have carbon fiber reinforced parts. They have outdone aluminum parts, and then they are 40% lighter, and mechanical properties, they are even better. Now, what 3D printing is doing is like, it's what it does is it's called distributed manufacturing. Now, it's very apt for military, be it Navy, Army, or the Air Force, where you have, a digital inventory, and then you have a global manager, and global manager could sit anywhere, even not in your country. He could be anywhere, and from there he could control the machines, and based on where it is required, he could fire that particular 3D printer which is in the close proximity and get the things done. So if you see, you can get it like immediately. You have a digital inventory, then you have a digital toolkit, and then you have got all those libraries which are again digital. One thing important and very important here is your data security. Digital world makes you more vulnerable. So ISO 27001 certification is for data security. If you have, then your data security is in place. Not that it cannot be breached, but then this is the standard which is globally accepted. And then since you have the data with you all the time, so this data can be stored for analysis and real time, with a feedback loop system, you can improve upon what you're doing. This is something well known to us, like forces and industries have to be prepared even for unexpected challenges. And yes, it is always unexpected. So you have to respond faster, you have to be secured, you have to be confident, and field deployment and flexibility is like on the go, on demand, on time. Coming to, making your weapons right at the field. So EOD Marines are working on several potential designs for the 3D printed containers that could potentially be used in the field as real explosives. So instead of what an ordnance factory would do, a 3D printing rapid logistics company can do it right at the field. And I don't think that it is something which is beyond our reach. It should be accomplished in very due course of time. Now coming to aircraft. US Marines, like I'm sure most of us know that American forces are deployed all across the globe. So in this case, the aircraft F-35 stealth fighter had some issues. So what they did was they 3D printed the component, fitted it on the aircraft, and the aircraft took off. Now the question is it correct? Is it the right aviation practice? Maybe no. But then here I have said use experience in place of certification because it is actual operation. Now, challenges. 3D printing or additive manufacturing is not something which is a one-stop solution for everything. So you have technological challenges, your materials, process implementation, and post-processing quality assurance. All these need to be standardized. IT standards are, again, they are needed. There's a skill set shortage. And then I think DGR should be doing something where we can sit with them and do some skilling of our own people to, go into the market. Then design principles are quite rigid, and 3D printing design principles are yet to be, evolved to the level where you have got those norms. And for anybody other than services, even in services, you have a business case calculation. How do you calculate whether you would go for a 3D printing or not? So the inputs are not so well placed in the market. There are capability challenges, like skill set is there as one. Then design and management courses offered related to manufacturing and production are not capable to deliver proper skill. We need to develop a force. Now, it's not a one-stop solution. Conventional manufacturing is going to stay. Additive manufacturing will coexist. Additive manufacturing will be for low volumes, high design complexities, and breakdown maintenance. Additive manufacturing and subtractive manufacturing will be complementing each other. How do you decide whether you should go for it or not? So these are quite laid down processes where you evaluate, then make a business case, then that's like have a roadmap, and then it does need a organizational shift in thinking in terms of MRO and manufacturing. Coming to materials, it's something which many people have a lot of anxiety about it. They are not sure whether 3D printing materials can actually deliver on site in operations. So you have got all kinds of 3D printing materials today. There are hundreds of them. So some of them are listed here, both metal and non-metal. Now, I would like to say that the 3D printing material has come of age, and today some of them can match the characteristics of a normal metal with ASTM certifications. So this is one where you have like 17.4 pH stainless steel. And if you look here, it is ASTM E8 standards, and equivalent is ASTM A564H900. So if you see the material properties, they are almost quite comparable. And therefore, it is said that you cannot have exact replication of what you had in a conventional setup, but you could have something which would be comparable, at times better, at times a little less, but then with the design considerations in place, you can get what you need, and therefore you can have a functional part. Cost effective, yes, people say it is cost effective. I would say it is yes and no, sometimes yes, sometimes no, and sometimes in operations, cost is not what is driving you, but it is the operations. So in the forces, we have to think both ways. And what is there in the PPT is like quite obvious. Say, for example, GE, the jet engine nozzles, it had 20 parts, and then you could reduce it into I think some 3 or 4 parts, and the weight was reduced by 25%. The 3D printed nodule was 5 times more durable, and you saved on cost. So now looking at 3D printing costs. So it's quite simple, like you have a material cost, you have assembly cost, tooling cost, production cost, and inventory cost. So these are quite simple to understand and assimilate. I will leave it here. Now, 3D printing. So what is here today, we need to be better off tomorrow. So the challenges which we have faced today should be obviated in the times to come. So you have now in process micrometer scanning. That means when your part is being fired, it is under production in 3D printing. At the same time, it is being, measured. And that measurement is being matched with the CAD file. And and that can be, so when the part is ready with you, you have a report also with you that what is the deviation from what the CAD file is. And those deviations, the AI is set up, what it does is it accommodates in its next 3D printing, and they are obviated. So this is what is the next in line, and I think its advent is already done. Now coming to negatives, like for everything there's a flip side. So you have like say cases where people have been charged with a criminal act and they have been indicted and jailed. So one of the such cases is like in UK, where somebody was supplying guns. Then Kent Edward, he was he was again manufacturing firearms. So what I see is that additive manufacturing in times to come is also having its negatives, and therefore measures have to be taken well in advance that they are checked and mitigated. What a little think about how do we go ahead? So surprise, like wargaming. We all know wargaming. It may be well thought, all possibilities considered, yet we can get surprised. Look at Ukraine-Russia war. I'm not much of a wargaming guy. I'm basically a MRO guy, but nevertheless, when I stretched my imagination, I found that neither ever Russia nor Ukraine would have wargamed an operational scenario as has unfolded now. There are two nations warring while several nations are active, supporting one against the other. And I have not added, but there are certain nations who are supporting both. The support is real, situational, physical, material, and psychological. I don't know if in India also there are such veterans here. They have ever wargamed something like this. If we have, I would be very happy. Therefore, the need is to ride ahead of the technology curves. If that is not in reach, one should ride the leading edge of the curve. That's what I think. And if there too one is lagging, then the adaptation of David's kind of strategy against Goliath, that be envisioned. What do I recommend? Every soldier should be an AM thinking engineer or soldier. I'm sorry, it should be AM thinking soldier. Adaptation by the echelons of the MOD, Army, Navy, Air Force, DPSUs, Coast Guard, and DRDO. The adaptation by all is good as of today, while it has to be great. The unfortunate or fortunate part is the gap is intangible. I would recommend ab initio training, adapt AM, there itself thus making all an AM thinking soldier. Additive manufacturing be made adaptive and ubiquitous. It should be well used for legacy systems, for Atmanirbhar Bharat and Make in India. Further, it should be done in-house in collaboration with echelons within the forces, like say in case of Army, Infantry and EME, Infantry and Engineer, all the three or whatever. And then Army, Air Force, Army, Navy, all the three. That collaboration can be seen, and then you collaborate with entities outside the MOD, be it academia, industries, and Indian as well as foreign OEMs. Quality and certification, which has to go side by side. So DGQA, DGAQA, and CIMLAC be always kept in the loop. What I say is you do not spend in technology, but invest. So the way war is fought is ever changing. A 3D printed drone can take on a tank and decimate it, while the tank cannot take on the drone. This is my statement. Anyone can contend or contest. And whatever I have said, which is relevant to military, is also relevant to industries. So with this, I thank you all and I close my presentation. Any questions? Thank you very much for the patience here.
Thank you, Group Captain Ashok. You have given an excellent expose, especially which has been very beneficial for the people who were not exposed to the 3D printing in a big way. And in addition, you have posed certain, challenges and directions in which we should move collectively for the nation's good. Before we take on the question and answers, we are privileged to have amongst us Mr. Prashant Sinha from Markforged India, who is himself, besides being an engineer, is an expert on additive manufacturing. So I shall request Prashant to cover his views on this subject for next 2 minutes, because time is overall not too much. So just in 2 minutes, just cover the salient issues, whatever you have to say about the additive manufacturing or the work which you are doing.
Thank you, sir. I'm privileged to be here to this event today. I think Mr. Ashok has very well covered some of the unique features of Markforged. I see a lot of there are software, which is the Eiger, which is a cloud-based architecture where the companies can take undue advantages because of most of the distributed manufacturing that cannot happen without this technology and cloud architecture. About Project Diamond. So the essence of Project Diamond is an initiative aimed at developing a distributed digital manufacturing network that enables a more agile supply chain, has the ability to immediately benefit local manufacturing economies by upskilling the workforce, and diversifies the types of technology and services business can employ. So Markforged is a member of National Center for Manufacturing, Sciences, and that builds 3D printers to enable government entities to fabricate robust, accurate parts when and where they are needed. Now, our Digital Forge is the only on-demand parts platform today which can go anywhere. You can manage a secure distributed network of 3D printers from anywhere with no need for skilled operators. You can drive advancements in research and development and fabricate parts out of the most advanced composites and metal available to 3D print today.
We are privileged to have amongst us Mr. Sarang Nerkar. Now, he is a gentleman of, unlimited capabilities. In fact, I have not come across any other person who is that much versatile in the technology as is he in my entire, service span so far. And so I will request him. He is, working on AR, VR, in host of, issues, modern technology, and especially not in the theoretical construct, but in translating that in the executive domain. So I will request Mr. Sarang Nerkar to share his thoughts in, say, about 3 minutes or so on this platform. Mr.
Thank you very much, sir. And thank you very much for having me here today. As sir mentioned, we are a company that works in the augmented reality and artificial intelligence domains. I would like to mention something about 3D printing. Along with 3D printing, sir, one of the key things that is there intellectually and in terms of intellectual property, that is 3D design. And that is something that we have been working on significantly. We have utilized 3D printing technology significantly in our product development. We are a company that is trying to work in the defense space without raising any external investment, entirely bootstrapped, that is based on our savings. And that is why 3D printing technology has really assisted us in being able to rapidly prototype a lot of our devices. And I would like to show you one of the devices that we have 3D printed. This is the augmented reality headset that has been developed by us, and it is entirely 3D printed, including the glass. So this development would have been extremely expensive if we went for the traditional 3D design and injection molding procedure. So just to give our own experience, not in terms of development of 3D printing, but just utilization of 3D printing, it has been an extremely useful technology for us. With that, I will close my remarks, and I sincerely thank you for giving me an opportunity to speak over here. Thank you very much.
Thank you very much, Sarang. It was actually really seeing the output, what the previous speakers have been speaking on the ground through your hands. And gentlemen, before I open the house for question and answers, we are privileged today to have amongst us Air Marshal R.K.S. Shera, PVSM, AVSM, and VSM, who has been, an expert of MRO, Air Force, as well as in the tri-services domain. In fact, he has lived with the MRO in and out, and we'll therefore request his expertise in next 3 odd minutes, sir. The time is short. We will have a deliberate session sometime later. If you can, share your inputs and recommendations for us, that will be really encouraging. Over to Air Marshal Shera.
Thanks, General Ashok. First of all, I'm privileged to be here, in fact, participating in this particular seminar or webinar. It's in fact General Matharu who prompted me to participate in this, because Though I was aware that there is MRO forum which is established, but this is the first time I'm in fact participating in this. And at the outset, I would compliment our dear friend Group Captain Ashok for such a well-researched topic, which is a novice topic for a lot of people. He has really covered it very well. Great job done by Ashok. Well, my experience with the 3D goes back to when I was at Maintenance Command as the SMSO there in 2016. That's the time we realized that in the Indian Air Force, especially the military MRO, when we talk of the fighter or transport or helicopter MRO, which we do in our BRDs, you may be aware that we have the base repair depots for all our machines, as well as the systems, that is the radar, missiles, and the other equipment which we have. But the major MROs of the aircraft happen at Kanpur, Chandigarh, and Ojar, and of course at Salud as well. So our problem which we have, certainly most of the people are aware, we have the machines which are mixed, all types of inventory. We have Russian mostly, we have Western, we have origin of Israel, UK, Germany, everywhere. So what happens is after a certain years of exploiting these machines, when we land up in the obsolescence area, we have a problem of acquiring those parts which we need to change during the MRO or during the overhaul, which we call mostly. So what Maintenance Command at Nagpur thought of was venturing into this 3D printing. And that's how I was instrumental in moving these things. First, we started outsourcing our 3D printing requirements. We did succeed in that, especially in the non-critical parts of the aircraft, where we could take probably a chance to experiment with the 3D. We got some confidence. Thereafter, we moved into looking into even the critical areas. So we also procured, in fact, we procured one 3D printer for one of our depots at Ojar, Nasik. So we are into it as far as Indian Air Force is concerned, as far as our overhaul processes are concerned. We are very much clear that, yes, when you have, as Group Captain Ashok said, it may not be a huge requirement, but when you require a part to overhaul an aircraft and the part is not coming from the OEM, you're stuck. It could be a mechanical part which is gone out of the factories of Russia or any other country. Now the solution which you find in this adaptive manufacturing is quite interesting. And that's how we started off. And today, as he said, we do boast of a lot of components which we have already manufactured, though they are mostly non-critical. That means non-flight safety components which we have manufactured or which we are engaged in manufacturing. We still have a long way to go as far as the critical parts are concerned, because issues involved are the certifications, issues involved are the testing requirements, the requirement of the materials, for that matter, even the contour mapping. When you have the parts which are complex, it's not very easy, and there is as such a skill shortage, no doubt. We ourselves are working on that, getting the training from various places. And unless I have the HR which can work on that, I can procure a 3D printer for 4 crores or 5 crores. But unless I have the required skilled HR, that machine will not deliver, because as you may be aware, to create those files, those software, the digital libraries, it needs a lot of hard work. So we are participating, we are taking help of even outsiders, maybe the academia, maybe the CSIR labs. Like I was telling General Matharu, we are in partnership with the CSIR lab here in Chandigarh called CSIO. They have a good 3D printer with them. So some components we have outsourced to them for manufacturing for our base repair depot at Chandigarh. So that is how Indian Air Force is looking at it. And we definitely recommend even the other two services to go the same way, because this is the technology which has a lot of importance for us from the obsolescence mitigation point of view. It may not be a commercial activity. I'm not saying that by developing 10 components for a Su-30 or a MiG-29 or a Mi-17 I have saved, or I will not even talk about saving of the currency or saving of anything, but it is something. If I manufacture that part, my operational capability goes up. I've got 10 aircraft in the air. So by just manufacturing those 10 parts, I have achieved something great. So that is how my vision at various levels. I had been the AOM at Delhi headquarters, I had been the CNC at Maintenance Command. So I'm fully convinced that this is a technology which we have to get on to. And there is no doubt we must work on that and take the help of the private industry, take the help of the academia, the research labs, and find good, sustainable solutions, and certainly overcome these certification issues as well as the procurement of the materials, whether we are able to produce indigenously, which is very few. So we should have some mechanism of procuring it from abroad as well. So that is what is my view on this. We are absolutely on to 3D printing. Thank you very much. Yes.
Thank you very much, sir, for your value points. Now we shall go to the question and answers. Anurag, could you go ahead, please?
So, in fact, it has been a very enlightening exposition of 3D printing, and I think it has come to a very viable culmination. But now getting more into the things, I would just like to bring out, sir, that even at a place at Pidagari, which is, one of the outskirts of Delhi, I had a chance to go to a place where they manufacture the new lights for all the new models of cars. And I had a task at hand to fabricate a pistol grip for a German weapon for my daughter and reduce it in size because the European size was big. So the 3D camera was a very simple elemental thing which was mounted, and there was a turntable on which a steel thali was up there. They painted the powder, sprayed my weapon part, which I had to replicate in 2 minutes, took an image, reduced it to, in a day's time, reduced it to a CAD, reduced the dimensions to my desire, and printed it at a cost of 3,500 rupees. So then that is what the start point was. Now, what I am trying to say is that, yes, for certifications for critical flight safety and operational things, we may like to go the long way. But in the short way, a 3D printer starts at a cost of, can be assembled, it was being assembled in a garage in Greater Noida, I was aware, by a EME officer's son. And it starts at about 40,000 and can go to a thing. Now that we have additive metal technologies, and we know the differences in foundry and forging techniques. So there's a whole vista. But making as Mr. Prashant Sinha from MaxForge, the sort of printers they were able to bring out plastic parts, our vehicles get obsolescent. Even the window covers, we are not, the handles, door handles, we are not able to fabricate. And we may like to take an early initiative. That is, I'm talking the Air Force, as Air Marshal Shera brought out. They are already into it. And I'm very sure so that I'm presently undergoing a course, a DGR course. And I would say that at your level, sir, I would request all the senior mentors here to bring this point that we are learning a lot of things, but to prepare people, learning skills like CAD and Pro Engineer, and going out and overseeing our requirements with our experience, I think we'll be able to really do well. And that was just it, sir, but it has been a very learning, and just to see this interest which has been generated by General Matharu is really inspiring. So I'm very sure we'll track along with.
Thanks, Anurag. Thank you very much for bringing out that personal experience and the advantages of 3D printing. Now we have Shri Pradeep Gupta ji, who has raised his hand. Gupta sir, please go ahead.
Thank you, sir, for allowing me to speak. At the outset, I thank for all the wonderful narration we had seen this today. It was very insightful, seeing that it is being used in the aircraft parts, what Group Captain Kumar told us. And of course, it was very heartening to see that Semilac is also involved, and they do some pre-testing or the approvals for it. I had just a suggestion to the top ex-top brass of the armed forces and the armed forces officers also here, that through this today's session, I will request, urge General Matharu to pitch in with the armed forces headquarters, whichever service receives it first, that to come up with a policy on integrating the additive manufacturing in their day-to-day functioning, at least in the maintenance activities and the operational activities. The persons who are the officers who are in the background, the maintenance people, they should adopt it. And if a policy is there, we know that this is the area it is allowed, this is the part this is to be made, this is the material to be used. So some kind of policy, and I'm very sure that with the kind of know-how, I'm really impressed with it, that we can come up with a very good policy. And just like the National Additive Manufacturing Policy, the armed forces can also come up, and it will be far better than what is in the civilian domain. That I can predict right now, seeing the discussion happening this year. This is just a short intervention I just wanted to make. Thank you.
Thank you very much, sir. Actually, you have given a lot of lead, the direction in which we have to work. So, gentlemen, all good things must come to an end, and not for end, but for new beginnings in the future. And it is therefore important that we hear General J.S. Matharu to give his closing address, who has conceived this idea of MRO Digest forums. He has served as DGIS and Commandant of MCEME in the Indian Army. He specializes in military vehicle technology, having done his master's from RMCS UK. He contributed to the design of the retrofitment of Vijayanta with T-72 engine. And I will hand you over to General Matharu for the closing remarks, please.
Jai Hind to you all. And first and foremost, I would like to thank General NB for giving his opening remarks for this, our first webinar. And to Group Captain Ashok Kumar Singh for giving a tremendous presentation, full of knowledge, full of information. And I would also like to thank each and every participant. I would like to thank especially Air Marshal Shera, who, like he's the CNC he has been, he's had very rich experience for joining on short notice. And in the end, I will just say that 3D printing has been there in the manufacturing sector for more than a couple of decades. However, it's still an emerging technology and has yet to find its place, I would say, in the manufacturing industry in the real sense. But now I feel that with the advent of artificial intelligence, things are going to change. And because what artificial intelligence brings in is that it can go back to the source of the design, and it can modify it, and that is very powerful as it's coming out from the presentations here. Many things can happen. So I have a feeling that this 3D printing technology will get influenced by both AI and machine learning. And I also feel that we may look at 3D printing as a technology to replace existing processes. But in a larger sense, this gives you a great amount of flexibility. For example, being able to produce a component at will is a very powerful option which has repeatedly emerged. And especially when a supply chain failure occurs, we know what how terrible that is. And this can literally be worth its weight in gold in a crisis. The benefits of being able to get a critical component printed in a battlefield scenario are obvious. But if we step back a little bit and look at designing itself, and we start designing our equipment with 3D printing or 3D printability in mind, then I think we get a very powerful scenario where the option of stocking a component or printing it as and when needed, both remain open. So for normal routine work, we could carry on using the component which is stocked and is much cheaper. And the more expensive option of 3D printing could be used in a crisis. So 3D printability as a design requirement, therefore, becomes important. And it is important that we delve into this subject in great depth and become leaders in 3D technology and remain ahead of the technology curve, as was so well brought out. We have done that in information technology. I don't see why we can't do it here. With that, that's all I have to say. Jai Hind to you all.
Thank you, General Matharu, sir. At the end, I thank each one of you for making this event a grand success. I think there were close to 40 participants for a notice of 7 days, and more than the number of participants, I think the qualitative participation was of a very, very high order. And we are privileged that you all gave your time. There is a belief, not only belief, it is truth also, that when you give your time to somebody, actually you are giving that part of your life to that individual or an organization. So MRO Digest Forum is grateful to each one of you for giving your time to us, and as our partners in this national growth story, we will be interacting more and more in the days to come. Thank you very much, and Jai Hind.